Welcome to the Data Analytics Practice Opportunity 2023-24 presentation session, organized by the CUHK Library. And this is the final event in the Research Data Management Week 2024 at CUHK. I'm Wendy, Research Data Librarian from the Library. This presentation session is held both online and in person in our Digital Scholarship Lab. In this session, 7 teams of students participating in the Data Analytics Practice Opportunity 2023-24 will share their project outcomes. We are glad to have invited Dr. Wong Kwong, Program Director and Senior Lecturer of Bachelor of Social Science Program in Data Science and Policy Studies to give comments to their works after their presentations. Before the students' presentation, may I first invite Mr. John Bahrij, the acting university librarian of our university, to give a welcome speech. Mr. Bahrij, please.
Thank you. Dr. Kwong, Dr. Wong, ladies and gentlemen, good afternoon. Welcome to this presentation session of the Data Analytics Practice Opportunity for this year. This presentation session is the closing event of our Research Data Management Week. Over the past week, we've had the Data Hack event and a workshop on the effective use of the CUHK Research Data Repository. We also launched the Data Champions at CUHK and an event on Wednesday. Yesterday, we learned from Professor Darch of the University of Illinois about the impact on culture and value by research data infrastructure in libraries. Today, in this presentation session, we'll learn about the projects by our students. This is the third year that the Data Analytics Practice Opportunity has been organised. It aims to engage students in creating data analytics and visualisation projects with data. In the call for applications last September, we attracted project proposals from 58 students who joined into 33 teams. We selected 7 teams with 16 postgraduate and undergraduate students from the faculties of Engineering, Science, Social Science, Medicine and Business Administration. Students with different backgrounds joined together and reused data resources available from our digital repository, the Research Data Repository, and a data collection set from the University of Hong Kong to explore different topics. 3 teams studied modern Chinese texts from the newspapers, such as the Hong Kong News and the Chinese Student Weekly, as well as the letters on the life of Chinese people in Cuba. Another 2 teams examined the classical Chinese texts from the Chinese medicine monograph Shang-Han-Lun and the text of the Zoumalou bamboo slips. The latest 2 teams investigated the electronic thesis and dissertation collection at CUHK and the Seagrass dataset from the Research Data Repository. The students had monthly meetings with our library team to share their progress and experience. This year, the coaches from our library came from the Digital Initiatives Department, University Service Centre for China Studies Collection, and the Research and Learning Support Department. We're also grateful for the advice and sharing and data from Dr. Kwong from the Department of History at Hong Kong Baptist University, Dr. Wang from Academia Sinica Centre for Digital Cultures, Ms. Cheong of CUHK, Professor Laura Falkenberg and Ms. Elisa Bass of the School of Life Sciences at CUHK. We'd also like to thank the ITSC department for providing ChatGPT services to our students and AWS for the support and some cloud resources. The students are creating posters, websites and interactive analytical tools to report their project outcomes. They will be displayed here in the Digital Scholarship Lab and on the DS Project website. This presentation session aims to allow students to share their work and experience further. After their presentations, we're pleased to have Dr. Wong, Program Director and Senior Lecturer, Bachelor of Social Science Program in Data Science and Policy Studies here at CUHK, to give comments to the students. We're grateful for your attendance for this presentation session. We hope you've enjoyed the activities throughout the week and have a better understanding of research data management and its development at CUHK. Finally, my thanks to all the library staff who work so hard to make these events a success. Thank you.
Thank you, Mr. Bahrij. Now, may I invite Dr. Wong to present certificates to the students. Dr. Wong, please. First of all, may I invite members of the team on Chinese in Cuba archive, Reappearance of Cuban,
Chinese life from 1955 to 1967. Liu Shengyu, please. Shengyu is a Year 2 student of the Quantitative Finance and Risk Management Science program. And then Zhu Han, please. Zhu Han is a Year 2 student of the Financial Technology program. Chen Hejiao, please. She is a Year 2 Computational Data Science program student. Next, let's invite Yulong-hin Nicholas, who is working on the project, The Wartime Story Under Japanese Occupation of Hong Kong. Nicholas is a Year 4 student from the Geography and Resource Management degree. Next, may I invite the team members of Enhancing Historical Insights, Name Entity Recognition, and Knowledge Graph Construction on the Chinese Student Weekly. Chik Jing-ho, John, please. Shek Ji-him Anson, please. Shun Yan-ho Joshua, please. They are Year 4 students of the Bachelor of Engineering in Artificial Intelligence, System and Technology. Then, may we have Chen Wei Yip Jackie and Bon Ji Wei from the team Compare and Contrast Formula in Shang-Han-Lun. They are Year 3 students from Computer Science and Chinese Medicine, respectively. We are glad to see this interdisciplinary collaboration. Next, we will invite Liu Liyu and Ma Heyan, both Year 2 students from Computer Science. They are working on the project's data translation and visualization based on Zoumalou slips. Then may we invite Raphael Dura and Chao Ji from Department of Sociology PhD program. They are working on the departmental landscape of CUHK, mapping ties using graduate thesis from 1967 to 2021. Finally, let's invite members of the team on investigating the impacts of marine heatwave on seagrass species on machine learning approach. They are Huang Chenbo, Da Zhihen, and they also have a member, Qi Hangmin, who is not available today. They are all Year 3 students from the Mathematics and Information Engineering program. Now, may I invite Dr. Wong, Mr. Bahrij, and all students to come forward for a group photo. With your certificates, please. Yeah, but you can stand at the front and the student will be around. Yeah, please. Two rows may be better, yeah. Show your face. Thank you very much. Now, it is the most important part of today's event, the presentations. After each presentation, we will have a quick question and answer time. If you have any questions, please type in the chat box of the Zoom room or ask after each presentation. First of all, let's invite Liu Shengyu, Zhu Han, and Chen He Chao to present their work on Chinese in Cuba archive, Reappearance of Cuban Chinese Life from 1955 to 1967.
Okay, hello everyone. We are the Cuban Chinese group, and I'm Amy. Okay, and the project topic today is the reappearance of the Cuban Chinese life from the 1955 to 1967. And in our presentation, we'll cover the following aspects. First is the introduction and background part, and next is the analyzing process and result, where we use the LDA model to analyze. And then is the visualization part, and finally is the conclusion part. So first is the introduction and background. And when it comes to immigrants, what will we think of? Maybe we'll think of those who immigrated to America or maybe Europe, and few will think of those to Cuba. But in our research, before the starting of our project, we found that in fact there were many Chinese who went to Cuba as immigrants. And they may first went there as the laborers, but they gradually lead their own lives. They integrated into the Cuban society, and then some of them have their own business, and others may spread the Chinese culture to the Cuban society. But there are few information about them, so we want to dig more about their life. So here comes our project. And our project focuses on the life of the Chinese immigrants in Cuba in the 1950s and the 1960s. And we focus on their life aspects of politics, business, finance, family, and education, etc. And we use the following two data sets. First is the family correspondence of overseas Chinese living string from the CUHK library. And this data set contains the family letter of the living strings family from in that period. And the second data set is the oral history of overseas Chinese in Cuba from the Hong Kong Institute of Humanities and Social Sciences. And this includes the compiled oral history. And we use both of these two data sets to do the analysis, to do the LDA modeling. And the final analysis is just based on the first data set, which is from the CUHK library. Yeah. And this is a demonstration of the data set from the CUHK library. And we can see that there are their letters and some pictures. And our analysis is based on the letters. Okay, and then Cindy will introduce our analyzing process.
Okay, now I'd like to introduce our experiment about LDA model. Firstly, I'd like to introduce the theory of LDA first. If you have some knowledge about machine learning, maybe you can learn from this name of LDA that it's a Bayesian model. For a Bayesian model, most distribution of the model we are unknown, but here we know only one distribution, W. W is a word distribution of each document. And here we give two prior, alpha and beta. Alpha is the per document topic distribution, and beta is the per topic word distribution. Then from some calculation, we can get Z. Z is a topic distribution of each word in each document. After have some knowledge of LDA model, maybe it will be more easier to understand the result of this model. Because LDA only extract words from the texts, but it will not give the exact name of the topics. Like here, we have no name of the topics. But we can conclude the topic name from here. Like for topic 0, there are some keywords like 政府, government, 民治, government by people, and 主席, president, 革命, revolution. And then we can conclude that maybe it's a topic about politics or revolution. But in fact, the name for other topics is not obviously enough, because in each topic there are some repeated words like 儿子, 女儿, which means sons, daughters. So we add some stop words. Okay. So we add some stop words about family relationships, like father, mother, son, daughter, and then we get a more obvious result. By the way, we still remains the original one version because we think family name the family relationships words are still very important for our noises because it reflects the connections between Cuban Chinese. And in this version 2 result, obviously we can find the name of each topics like in topic 5, it's still a topic about politics or revolution. And in topic 7, there are some words like restaurant, 餐厅, 餐馆, 杂货店, store, and so on. So we can conclude that it's a topic about small business of Cuban Chinese.
Okay, and after we get the LDA result, we can extract the topic from each letter. And we use this Excel function to get the number of appearance of each keywords from each family letter. And we use this to extract the topic. And the final result is like this. Next. It's like this. And you can see that column A is the letter of the original family letters, and column B is the data of the letters, and column C to G is our 5 extracted topics. And if the topic matches the original letter, we will show the corresponding topic in the cell. And if it doesn't match, then we will just write 0. And next is the visualization.
Okay, now I'd like to introduce LDA visualization first by implying the Pi LDA viz package. We get the LDA visualization result. It's a HTML file, which means that we can open the website of this file and do some interaction with it. And we also post the links in our own website, and if you are interested in it, you can visit our website. And here's the visualization result of LDA. You can click on the circle of topics, and it will give us several keywords of these topics. Like we can conclude that it's a topic about small business. And also we can click on those keywords, and it will tell you that those words belong to which topics. It not only belong to one topic, it is also possible to belong several topics. And also we can analyze the axis of this graph. Like we will click on topic 5, and it will give us some keywords about travel, about hometown, and we can, and it indicates that it may be belong to some words about the Cuban Chinese hometown. Also, we can click on topic 7, and we will easily find that there are some words about Cuban lives. So maybe the vertical axis is about the life between hometown and Cuba. Now we'd like to introduce our other visualization results.
Okay, now it's the timeline, and we use the NetLab platform to do this visualization. And you can see that in this part there are some the timeline, and this is the topic of each letter. And you can roll this row, and you can click on the topic that you want to see, and the upper one is the original letter. And yeah, you can see it in detail. Okay. And you can see that this is the website, and we have already put it in our formal website. And you can roll this column and click on the topic and it will show the letter. Yeah. And next is our next visualization step.
Okay, well, so aside from the timeline visualization, we have also added some other kinds of visualization. And the first one we want to introduce you to is the bar chart race. Because from the timeline, we could see that it will provide you a rather so rough data with the original text. So we would like to show a more direct and more dynamic way for the viewers to get a direct feeling about how the topic changes through the period. So here is our bar chart race. Yes, as you can see here, like it will demonstrate like on each specific year, like in the 1958, and the proportion of different topic here, and you could also see the different topic race against each other and how they changes. So from these, we will get a more direct feeling and feedback, like what is the main focus of the Chinese in Cuba during different periods. The next period. Yeah, and then the next, we also added a word clouds because the timeline and the bar chart race all focus on the topics, but actually we derived the topic out from the keywords. So we suppose that if we demonstrate the keywords, it will help the viewers to gain a better understanding, a more specific understanding of how the words most frequently repeated in a specific period. Next slide, please. It's like in the next slide, you can see that the timeline is being separated, divided into 3 groups. Each contains 4 to 5 years. And this one, it shows like the words most frequently in each one. As we could see from the word cases, it is more specific than the previous visualization. Like we could see this home and the family life actually appears all the time, so we may draw a conclusion like it remained a large proportion during this period from 1955 to 1967. And also we could find some interesting conclusion like those purple government words and the words of like the promising future, they appeared in the 1960s and the word is becoming larger, which means their frequency increases along this time. So from this, we will see more clearly like how their life focus has changes. The next, please. So here comes to our conclusion. First of all, we would like to walk you through of all the large or big events happened during the 1955 to 1967. As you can see here, during this time, actually, they are very shaking ages for Cuba, with a lot of revolutions, different political policies and the change of governments, also different kinds of big events that affects people's life very severely. So next slide, please. And if we combine those timelines with our visualization together, we will see like as you could see here, actually they marches with each time period, and we could see that both of the visualizations show some similarity. For example, we could see like starting from the 1960s, the focus changed more to politics and homeland. Like we could also see there this word financial exchange. It means like you send money back to your hometown. And from this one, you could also see this orange one is the same with this. And this yellow one means the politics. We could also see like the word for government has increases. So all of the visualization actually from this, we may find like, if we look at big events, we may guess like starting from the 1960s, people may become more concerned about their own money resources, their family, or about their political environment. And our LD analysis of about 200 family letters actually tell us that they did. These could be reflected on their family letters. And from these, we will see that far away from the 15 years ago and to the country departed from another ocean, because that the life echo in this research. And thank you all for that. Next slide. Thanks.
Thank you, Songyu, Zhuhan, and He Chao. And does the audience here have any questions for them? If not, may I ask you a question that what difficulties did you encounter throughout the whole process of research and doing these projects, and how you try to overcome these problems? Since I can see that there are a lot of visualizations, and the interaction between different visualizations is very interesting.
In fact, when we began to do the LDA analysis, we find, because at first we don't add any stop word, and we find that the result of the topics are very ambiguous. And in fact, we asked for help to Wendy, and Wendy tell us maybe we can add some stop word, and you can combine two data sets together. And then we get a better result, and we can easily conclude the topic name of those topics.
Yes, and also like the creation of other kind of visualization is also inspired by the help of our librarians, because at first we wanted to use text tour as a complement for our timeline, but later we found it cannot work because it cannot reflect the changes of all of these topics or words very clearly. So like we seek help from our librarians, and thanks to them, like we found there are other ways, there are other various kinds of ways that we could try to do this in another part.
Thanks for sharing. That the help for this group is a lot from Miriam, who is our China study librarian, and also Vincent helped a lot with them during the process of overcoming all those problems. And I hope this sharing would be good for other future students to do data analytics projects, how to solve the problem, for what kind of directions they can go forward. Is there any other questions? Yes, Dr. Wong.
Yeah, I would like to know about the software you use for the visualization, for the NLP.
Maybe we change it back to, is it about the timeline or the bar chart race? Because actually we use three kind of different software, two kinds. This one is from the Night Lab because it is used for timeline specifically, and the other two actually we use Flourish. Yeah, it's like we pre-process our data in Excel, and we plot the data into that platform, and with the help of that we can draw the bar chart race and also the word cloud.
Any more questions? If no, then thank you very much for you three. It's very interesting projects. And next, may we invite Nicholas Yu to share his projects on the wartime story under Japanese occupation of Hong Kong. Thank you, Nicholas.
Okay, so good afternoon, everyone. Good afternoon, Dr. Kwong and Dr. Wong, and all the guests attending here today. I'm Nicholas Yu. I am an undergraduate, a final year student at the Department of Geography and Resource Management, and I'm a final year student. So today I'm going to share about my project topic. It's about the wartime story under the Japanese occupation of Hong Kong by using an early newspaper, the Hong Kong News. So first of all, let me just introduce some background or the motive that I do this research. So as most of you know, during the occupation of Hong Kong, there are nearly no newspapers. They're all seized. However, there is one a tabloid newspaper named the Hong Kong News. It's actually kind of like the official is owned by the Japanese government. And then in the past research, most of the research like Dr. Kwong's one, they are focusing on the war, the tactics, how they overcome the war, how they battle. But kind of like a limited research really focused on the livelihood and the life story under the Japanese occupation. So here's why I really want to do this research. And luckily, the CUHK do have a very cohesive collection of the Hong Kong News. so I can do this research then. So here are some of the methodologies that I want to share with you. So first, the newspaper is like this. It's brown, it's yellowish, and is not able to do any OCR, and which is why I need to do some pre-process of the image by using the Photoshop, tuning and adjusting the color tone, the black and white contrast, and then we can come up with the right one, which we can really now ready for the OCR. And then I would like to introduce this software, ABBYY. It is actually available in CUHK. It is a software to do the OCR when you insert any file, insert any PDF, and then they will export and really look through the test and outcome with different formats. So here in this research, I tend to use the HTML format, which will be discussed later why I use the HTML format. And then I will use the Python, which is the beautiful soup, as a function in Python, which is to extract the text from the newspaper. Because I would like to explain more here. Because what I want to do in the research is a section in the newspaper, which is the around town, you can see here. And it is, I think it's in the third page or the second page of each issue. So what I'm going to do here is I need to extract all the text in around town after or under that section. So I have to big use of the beautiful soup in Python, and then I will have this result locating the text here, and I also inserted some rows like the category, the latitude and longitude of the location. So then after the OCR, it is not really perfect, but I think it's 90 or 95% something perfect, but some final adjustment should be done here. Like when we see these unwanted characters, or even we have Chinese characters here, which is not really optimal for visualizing or for research. So I have made use of the Python again to erase those unwanted characters. And then the right one, the finalized test is ready for do some analysis, finally. So here again, I have used another product, another software by CUHK, which is the name entity recognition, the CUHK ChatGPT. So in bygone days, maybe we use Python or other software to do the NER. And maybe it's kind of like time consuming, but here on the advent of technology, we can use the ChatGPT, where I only ask one question to ask the ChatGPT to extract the place and the full sentence. And then they will come up with these results, like the place and the exact sentence. So it is very convenient, and it's a very amazed technology here. Then I have liaised with the owner of the Hong Kong historical maps, HA Maps, and I have borrowed some historical maps. Like this one is the 1945 maps, because we really want to use case of the historical maps of that time. And then the owner of the maps already have georeferenced it, so I can just insert the map tile into the ArcGIS, and then you can see it's here. It's already nicely placed in the map. And then coming to the final stage, I use ArcGIS Pro and ArcGIS Online and ArcGIS Story Map to do my visualization and also the interactive story maps. So we will showcase and demonstrate later. So here are some simple statistics here. The one that CUHK possesses 516 issues, and then I have categorized it into 6 different categories. and there are 300 new places in the newspaper and 53 districts and streets. And also I have come up with nearly 800 stories or issues in the test. So here are some findings. The first one is when I do the research, when I do the analysis, there are some places that I cannot figure out immediately. Here are some examples. Actually, there are one black market that appear quite frequently in the test. First I think about where is the black market, but actually after some research and analysis, I know that it is actually referring to the underground economy, the illegal, the unauthorized economy, 即係黑市. And then Yulok Theater, it's actually the entertainment building is still here in Central. And then the Ming Road in Xiangshui is actually the Taimalu in Xiangshui, the Sanfeng Avenue, which is still here today. And lastly, it's North Temple Street. It's actually the northern part of Jordan Road, the northern tip. And then another finding is that I think, or I kind of summarize that actually there are different names to describe the same place, which is like Mui Wo, they will use different war and war, which is actually the same pronunciation, and Nangqiang and Nangqiang. So here what I want to say is they have different name, different different name to describe the same place. I kind of think it's unorganized. Maybe that at that time in the wartime they are not really focusing on the accuracy, and which makes this result here. And the finding 3 is actually quite, I think it's a quite interesting finding. In one of the tests, in one of the issues, they say that the Stonecutter Island has been renamed as Mokojima, and actually it's a new finding because in the website or in Wikipedia, they did not have this recorded. So I think it is kind of an innovative one, a new discovery that is not shown before. And then I want to show the live 80 years ago. You can see from some tests, actually there are some entertainment, even though there are war and battle at that time. I will summarize in the next slide, which is here. There are actually 2 amusement centers at that time. One in Shek Tong Choi in Hong Kong Island, and one in Sham Shui Po in the Kowloon Peninsula. And there are actually quite a vivid, I would say, a vivid and vibrant entertainment activity, like restaurant, cafe, massage houses, and hotel and skating rink. But the interesting one is that in 1943, the middle of 1943, the government has seized all the amusement activities and say that they will not revive in quite a period of time. And then finding 5 is the shortage of electricity and the fuel, which can be seen from these 2 tests. This is about the farm, the Hong Kong farm, the milk. They are actually affecting the supply of milk due to the shortage of electricity. And the right test is about the tram. The tram service has been suspended or shortened into a quite short period of time due to the shortage of fuel. And this is another finding that I see. So here is the visualization. Of course, I will upload a database of the all around town issue, the all 516 issue, which we can see later. And I think there are some non-spatial issue, or some did not describe the place, but it's also very useful for future finding and future research, which may be used by the CUHK or even the public can use it. And then I will have a glossary of the Japanese district and street names, and also a glossary of different Japanese place names, like the restaurant, like the primary school names there. And then I want to show you a story map here. So this is generated by RG story map. Here is the background that we have covered. We have go through the significance, the statistics we have covered also, and the time slice. Okay, so I click this button, and then we show where are the issues happen. So you can see from in the year 1944, you can see, this moment. There are no issues. There are no places that time. I think there are two reasons to explain this. One is our CUHK did not have that collection at that time, or another reason is the Hong Kong news did not publish at that time, because I have seen research, there are shortage of everything, so maybe they did not publish any issue at that time in the year 1944. So yeah, here the methodology, and this is the interactive map. So there are some legend here and the map, and by clicking each of the legend like this. So this is an incident happened in 1943 to January 27th in a Thailand Liu village, and it says that there is a hill fire occurred at the back of Thailand Liu village, and is now being examined by the Taipo, the government official. So by clicking different legend, you can see the time, the latitude, longitude, the location, the category, and also the exact text from the Hong Kong news. So yeah, you can try it out. I will put it in the website later. So here, we're back here. By the end of March, I think it's nearly 2 weeks later, all of this will be uploaded on website, and you can make use of everything. You can enjoy the interactive map, and also the story map is in our CUHK library data repository website. So at last, some acknowledgement, because we have garnered some opinion or suggestion from you. So here is also an acknowledgement, and also the owner of the Hong Kong map, and thank you so much for his help. So yes, this is very much that I want to say today. Thank you, everyone.
Thank you, Nicholas. And any questions from the audience? Yes.
Thank you, Nicholas, for the most interesting presentation. And did I help? I'm not sure. I just.
You provide any suggestion to Kitty and I. So
so I did. Okay. Anyway, I have some comments and questions, and one of course concerns the source, because you use Hong Kong news, right? Have you considered adding at the later stage, okay, if possible, the Chinese newspapers, because Hong Kong news was more official than other officially backed papers. So they basically only highlight good things happening in a very bad situation. So that's one thing. And on the other hand, have you considered adding a 3D terrain model for the map? That's one thing, because you have ArcGIS. So it's fairly easy to just convert it into 3D. So do you think, would it help to allow us to see more things through a 3D terrain model?
I have tried the 3D map, and I think it's probably a good try, maybe to visualize it in a 3D option, and also about the source of the newspaper in the early stage, like at the start, I really want to use the Chinese OCR, but the performance was not really great. Yeah, so at this stage, I will use English first, and maybe in free time or in future or in due course, maybe there's also a possibility to use the Chinese text, because yes, it is an official owned newspaper, and they kind of like 報喜不報憂 and yeah, so there are some future possible ways to do it.
And two more follow-ups. One thing is about the ChatGPT. I really am amazed by that particular part. So you created it?
No.
You just
make
created
use
a
of it,
prompt, right? So
Yeah.
you think of a prompt that allows it to separate the location and the name.
I provide a training example to it has to be place one, comma, and the exact sentence one, and then I throw the whole text to them, and they will generate into the format that I provided or required. Yeah.
All right, that's how you really use it. Thank you. I have a lot more to ask after this. Okay, thank you. Exemplary. Thank you.
Ryan.
Yes. Wait. So one follow-up question about the ChatGPT. So you mentioned about this is quite amazing tools, right? Have you observed any drawback when you're using the ChatGPT when you extract doing the NER, or is it perfect tools? Or
I think the largest limitation of using ChatGPT is token limit because it has limited into I think it's 4,000 or 8,000. I cannot remember the exact number, but you can always refresh it and throw the test and request it. So maybe it's just a matter of time. But overall speaking, I think the ChatGPT is really useful in doing the NDR. And I think other groups will share about different usage of ChatGPT later. Yeah.
Thank you very much, Nicholas, and all the questions and comments, and very comprehensive work here. Thank you, Nicholas. Next, we will have John Chick. We will have John Chick, Anson Shek, and Joshua Sen to introduce their projects enhancing historical insights, name entity recognition, and knowledge graph construction on the Chinese Students Weekly. John, Anson, and Joshua, please.
Good afternoon, everyone. I'm John, and he's Anson, he's Joshua. Our topic is enhancing historical insights, named entity recognition and knowledge graph construction on the Chinese Student Weekly with ChatGPT. So let's get started. We will talk about our motivation, the methods, and the results, and the future works. So let's start with the motivation. Let's talk about this at first. Okay, we are using the Chinese Student Weekly. So it is a Hong Kong newspaper published between 1952 to 1974. So in total, there are 1,128 issues published. So at first, it started as a single sheet publication in the 1950s. So it's expanded, okay, to 3 to 4 sheets in the 1960s. So it nurtured and showcased important contemporary Hong Kong literature authors, and also captured the pulse of the era and in preserving invariable cultural heritage, okay? But for the general public, for them to learn the history through the newspaper, there are some difficulties, right? So, for example, the newspaper is just too long. And in this project, we are choosing the 10 years of newspaper from 1953 to 1962. So it's already 27.4 million characters. So it's just too long, just discouraging the public to know about it. And also, if you're willing to read the newspaper, reading thousands of newspaper articles can take a lot of time. And it is also hard to discover the relationship between events that occurred across different months or years just by reading the newspaper. So here the solution is that we will construct a knowledge graph on the newspaper. So what is a knowledge graph? So knowledge graph is a structured representation of information. So it organizes and connects entities, concepts, and relationships. So you can refer this graph. So here's a note, Bob, he's a person, and he's born on 1990s. You can know the information from this graph easily without reading his biography, okay? So if we mentioned about the entities, so how can we extract the entities from the passage? So we will do the named entity recognition. So what does that mean? It locates the named entities in the text, and it classifies them into the predefined categories. So we defined organization, location, event, person, and date. So here's an example, Apple. Okay, from this example, we will extract those 5 categories by using NER. Okay, and then to increase the NER accuracy, we need to do some text pre-processing because the newspaper, the text is collected from the OCR. Well, due to the printing quality and the capability of OCR models, the text actually, some characters are misrecognized. So we need to remove the noise and correct the misrecognized Chinese character to improve the accuracy of the name entity recognition. So here's an overview. We will do the text modification first, and then do the NER, and based on the collected entities, we will construct a knowledge graph. So here, how can we do this task? So we will use ChatGPT 3.5 to help us to do the first 2 tasks, the text modification, as well as the named entity recognition. So what is it? Well, it is a large language model developed by OpenAI. So LLM itself is knowledgeable and is good at following instructions. So for us, we don't need to train our own model, okay? And it understands and generates human-like response. Here's the advantage is that, it can understand the context, and based on its own knowledge, it may be helpful for us to do the predefined tasks. And it is also easy, because we don't need to train our own model. But the disadvantage is that, it may provide some inaccurate information, and we need to pay for each call, So here comes Anson, who will talk about the text multiplication as well as the name entity recognition.
Okay, so thank you, John, for the motivation of our task, and I will focus on the technical parts of our project. So first is on character modification, which is one of the pre-processing process. So as mentioned by John, the Chinese Student Weekly, we have the full text available through some OCR software. But since OCR software is kind of weak in recognizing Chinese character, the full text often contains error that may impede the understanding. So our goal is to identify the inconsistencies in the text and to make some appropriate correction through ChatGPT. So we have summarized some common errors by the OCR software, including firstly, misrecognizing the punctuation mark. Like for example, for the plus sign and the Chinese character sub. They are similar in shape, and it's really common for the OCR software to misrecognize it. And the second one is full stop, and the Chinese full stop is kind of similar as dots. And also for the third one is the high stroke density character. For example, like tan, and you can see that the stroke are like compact in one character. So we, from our observation, we also find that this kind of character is also hard for OCR software to find out. And the fourth one is the incorrect radical. So there may be some error that will occur in identifying and assigning some correct radical for a character. So, and then we will utilize the ChatGPT in order to complete this task. Our prompt is using like this, we have a translator query in English, to give the ChatGPT the objective of our task is to correct the incorrect Chinese character or words extracted by OCR in the following Hong Kong article. So the ChatGPT will try to understand your prompts, like ChatGPT have natural language understanding, and they try to will also give the passage to it, and it will try to use its own understanding and try to predict whether the words are correct or not. So this is not like ChatGPT are not directly extract the words from the image of the newspaper, but it tries to use its understanding from the pre-training part and to try to guess whether the words are correct or not. So from our results, we find that around 9% of the test character is actually corrected. So, this is one example of our results. Like before modification, they may find 今年幾 and we change it to 二 and for example 其中 is actually 朗中 like full stop actually the OCL software have O and we try to correct it into dots the full stop but actually there are also some kind of weakness for ChatGPT, for example like some kind of 其中 is not corrected. Right. So we find that the ChatGPT in a company achieving this task in a relatively high rate, but actually they do have some kind of character that they cannot correct. But like most of it, you can try to correct it. And for the results, we have some statistic here. We have modified like 3 million characters out of 27 million, which is around 12%. And the we define modification is like either deleted or corrected. Okay. And for the second part of our project is actually the name entity recognition, and our objective is to analyze the unstructured text to identify some important details. As mentioned by John, we'll try to extract the importance entity and try to find out the relationship between the entities. To complete this task, we also utilize the ChatGPT, but in addition to that, we utilize some skills from the prompt engineering. So it is common for prompt engineer to utilize a skills called field shot learning, which is to give examples to ChatGPT. For example, the objective is to like assist GPT in understanding what we want and what we will try to input. To give examples, there's example for example, we will have 5-shot learning. Like for 5-shot learning, it means we give, in addition to the prompt we give to GPT, we also give 5 examples during the prompting. And this will increase the accuracy and like the outputs will be more aligned to what's our expectation. This is one example. For example, we'll have the newspaper there and we try, after OCR we get this, and after test correction we get this. And we give the whole passage and also the prompts to ChatGPT, and it will try to extract like person, location. For example, Yuan Shaolan, Chen Yukdat. These are the person that ChatGPT recognizes it and try to extract it. And they have also some location here, and the ChatGPT also output the relationship between these kinds of entities. For example, Yuan Shaolan resides in 英皇道, and she's interested in 文藝電影 and 雜誌, right? So I will pass the time to Joshua on the knowledge graph.
Thank you, Anton. Now, let's talk about how we can construct the knowledge graph from the recognized name entities. So, to recap, we have something called a knowledge graph, and to visualize our knowledge graph, the named entities will be nodes, and the relationships observed by ChatGPT will be the edges in the node. And we utilize the Neo4j graph database software to store and query the graph data. And for example, its query language is called Cypher, and its syntax looks something like this, which will output a graph showing how John is a roommate of Anson. And quantitatively, our NER algorithm was ran for 10 years, and here we can see the number of relationships in orange and number of nodes in blue for each year. And in total, there are 80,000 nodes and 114,000 relationships. To explore the graph, we want to find something more interesting from the graph. So we apply three algorithms. The first is called degreenness, which measures how many nodes are connected to a particular node, and we output the nodes with the most connections. Another algorithm called PageRank, developed by Google, and then we also try to find clusters or communities inside the graph using something called label propagation. So let's take a look at how they work. So as mentioned just now, degree is the number of nodes connected to a graph, so A has a degree of 2. So we run the degree calculation for the graph, and we see that the word "我," meaning me, has the most amount of connections. This is because inside our data set, there's actually a lot of writings that are not related to news, but maybe people write their daily observations, or maybe it's some type of novel. So the word me appears a lot of the time. And this is what the graph looks like. Seems like the resolution is not too good, but we can see that me is connected to many different things. However, this me is different in each article. So we think that degree is not actually a good measure of the central nodes inside our graph, because each me is talking about a different event, and the events or the articles are actually very disconnected from each other. So we applied the next algorithm, PageRank, which essentially treats each node as a page and imagine the relationships as links where the nodes where you can click to different pages. And we see which pages appears most frequently, and they will have the highest score. So using the PageRank algorithm, we see that Hong Kong, China, America, Kowloon, Japan, and I think this is Taiwan. So they have a very high score, meaning in those 10 years, actually, they are the nodes most related to the most number of articles. So they are the more important nodes inside the newsletter. So we can see the graph for Hong Kong. It is connected to, say, this should be South China Morning Post. It's connected to different regions in Hong Kong. So the colors represent different types. So for example, purple is a location, orange is an organization, blue is a person, and there should be, anyways, so we can see how they are connected. Okay, and we also see Kowloon. And lastly, we apply label propagation. So we find different communities. The first community is very big, and let's take a look at the second community. It's someone called Miss Lee, and she wins everything. So I look it up, and why she wins? It's because, next page. She is the winner of a lottery. Okay, so I think time is up, and let's pass the time to the audience. Okay, so to summarize, we see that the methods we used provide interesting results, and they find interesting communities and central nodes inside the graph. However, upon further inspection, we see that some nodes don't really accurately, they're not accurate. For example, the classification would be incorrect, or some of the characters would still be wrong due to problems in the OCR. So we hope that we can improve accuracy, and we also know that each article has a timestamp. So we hope that in our future we can visualize the relationships through time as well. But I think overall it still provides a lot of useful insight towards the analysis of the Chinese Student Weekly. Thank you.
Thank you, John, Anson, and Joshua. Very interesting analysis on the Chinese Student Weekly. Any questions from the audience or from the Zoom room? If no, may I ask you a question that because you have been employing ChatGPT for some while and to explore the Chinese Student Weekly. So how do you think about, how do you compare the ChatGPT with other NER analysis by using other traditional programming methods, for example, Python and others too?
Well, to use ChatGPT, first of all, here, okay, you don't need to train your own model to do certain tasks, okay? If you train your own model, you need to gather the training data sets. You need to take some time to train it, okay? And you usually just train it for a specific task. Oh, for example, this model, I train it for NER, and it only can do NER. However, if you use the ChatGPT, first of all, you don't need to train. You just need to fine-tune your prompts to instruct the ChatGPT to do tasks for you. So here I use task modification as well as NER. We don't need to train two models. We just use ChatGPT. So it is very convenient to do that. Oh, okay. And in this project, it's not only about the reuse of data of Chinese Student Weekly. It's also, I would say, an evaluation on the capability of using ChatGPT. Yeah.
Yeah, they have been working on the ChatGPT and explore the functions on how ChatGPT could work further and the capability of ChatGPT. So this is an interesting project, and I hope this project will be useful for them, especially when they are studying AI and they are graduating and going to further study or work in the field in the coming year. And thank you very much for all the presentations here, and thank you, the three of you. And now we will have a 10 minutes break. So the time is now 2:40, and we will start resume again at 2:50. Thank you. So welcome back to the Data Analytics Practice Opportunity 2023 and 24 presentation session. After the presentation by three teams of working on some modern tests, now we will move into two projects on Chinese classical text. First of all, let's welcome Jackie Chen and Peng Wei to share with us their projects on compare and contrast formula in Shang-Han-Lun. Jackie and Peng, please.
Good morning, everyone. We are the group of compare and contrast formulae in Shang-Han-Lun. He is Jackie. I am Peng. Okay, this is our content today, and we will go through it step by step. Okay. In Chinese medicine, we use herbs to treat disease, and some ingredients are often used together because there are complicated interactions between different herbs. Okay, so in different formula, there may be same drug combinations included. Their similar disease are treated by different formulae, but they include the same combinations. But there are also many other different herbs included. Okay, so we wish to build a searching tool for Chinese medicine students to help them analyze the relationships between the same drug combinations and different herbs in different formulae. Okay, Shang-Han-Lun in English, it can be translated to about being harmed by the cold, which is an epidemic. Zhang Zhongjing is a writer, and in his author's preface, he said that in my family, there were 200 members, but 2/3 of them died. More than 70% of them are caused by the cold. So we can see that the Shang-Han-Lun was written to treat patients with the cold. Okay, so in Shang-Han-Lun, we can see Zhang Zhongjing levels 112 formulae using only 89 ingredients. Okay, this is our working progress. We first select pages from Zhongjing Quanshu, and then we have go through the OCR using two OCR platforms, which are the AICDC, the Academia Sinica Center for Digital Cultures, and the other one is Gujiku. And then we extract the text and combine them. Okay, and then we perform formula modeling. After that, we have the visualization and we come up with the interactive graphs, and we build a formula origin finder. Okay, we know that Zhang Zhongjing wrote the book Shang-Han-Lun, and there are a few more people who annotate and process Shang-Han-Lun and put it in the Zhongjing Quanshu, okay, in the volume 1 to 3. Okay, this is the image showing Ma Wong Tong, which is a famous formula in the Shang-Han-Lun. Okay, let me first introduce Ma Wong Tong. Ma Wong Tong is one of the famous and representative formula from Shang-Han-Lun. Generally, we may say that Ma Wong Tong is used to treat patients with cold, which shows the following symptoms, such as cough and shortness of breathing, and etc. Okay, we can see that 4 herbs are included in this formula. They are gamqiu, guaizi, ma wong, and hanyan, which is almond in English. Okay, so next please Jackie to introduce our OCR stage.
Thank you. OCR is the first stage of our workflow. We have employed 2 platforms, namely the ASCDC platform and CUHK platform. ASCDC provides a user-friendly interface for OCR. It can recognize most of the words with 91% accuracy. Sometimes the OCR engine cannot recognize some of the words, and we can manually proofread them. However, there are some side and top annotations in the original images. The OCR engine sometimes mixes up the annotation text with the content part, so we decided to remove all the annotations programmatically using OpenCV. After the removal of annotation, we will pass the processed image to CUHK platform. CUHK OCR has provided us with 10,000 API quotas. Also, their OCR engine performed well in recognizing parallel lines of text, resulting in a more accurate line segmentation. Here is one of the OCR results. By observing the passages, we have identified some terminal keyword. The start keyword usually is the formula name. Here, the starting keyword is Ma Wong Tong Fong. And the ending keyword usually describes the number of herbs used in the formula or the derivation from the parent formula. In this example, the ending keyword is Yao Sei Mei. And we need to have a look at one of the ending keyword Yu, because this usually indicates that the current formula is derived from another formula. In this example, 貴之加父之湯方 is derived from 貴之湯方. Now we have completed the formula separation stage. We need to merge them together. On the left are the OCR results from the 2 platforms, and we will carry out manual comparison and merge them into the result on the right. The manual comparison is done on the Chinese text project platform. Its diff2 can identify and highlight differences between 2 passages. This speeds up our process. Finally, we can model the formula in 3 ways, as shown in 3 tables here. The first table is filled with Chinese quantity as stated in Shang-Han-Lun, and the second table is filled with quantity in grams. Note that different herbs use different units. For example, gamqiu uses 兩 and hanyan uses 個. After some research, we converted the units to grams. And in the third table, it is 1 hot encoder. If the herb is present in the formula, we will fill it with 1. Otherwise, it is filled with 0.
A critical part in formula modeling is to identify the herb name correctly. Fortunately, ASCDC has provided us with a comprehensive Chinese medicine list. Moreover, the team of text analysis on collected exegesis of recipes in Data Analytics Practice Opportunity 2021 to 2022 has also added some herbs to the list so that we can identify the herb and their dosage correctly. To sum up the pre-analysis progress, we have extracted the information from the images. The information ranges from the metadata to the structural representation of the formula content. In the next section, Pong Pong will share the findings and visualizations for us.
Okay, this is an interesting diagram showing the formulae in Shang-Han-Lun. We can see that the green and the purple sectors together occupy more than a half in this diagram. This can be explained because we can see that this formulae actually heals the disease called Taiyuan. And Taiyuan in TCM in Chinese medicine theory is recognized as the first line of defense in human body. So the disease factors always attack human body in this layer first. Okay, so this is impressive for me as a Chinese medicine student because we can see that Zhang Zhongjing is very careful and and he tried to treat patients at the very early stage in the course of disease. Okay, this diagram shows the top 10 commonly used herbs in Shang-Han-Lun. So in the red box, we can see that out of the 10 commonly used herbs, 8 of them have the property of hotness. So after all, the disease in the Shang-Han-Lun are mostly the cold. Okay, so we use the hot medicine. Okay, so 3 out of the top 4 commonly used herbs are these 3. And so in Chinese medicine, we will say they can replenish our internal energy. And this shows us the fact that in Chinese medicine, we focus on people's internal energy. This is a heat map showing the differences across the herbs. The darker color shows the higher similarity, and the lighter color shows the lower similarity. For example, we can see in the red circle, it shows that the guaizi and the CUHK, these 2 herbs are positively correlated, which means that they are often used together and also with the similar dosages in Shang-Han-Lun. Oppositely, we can see Sangang and Gonggang in the blue circle. They have the relationship of negatively correlations, which means that they're not oftenly used together in Shang-Han-Lun. Okay, this shows this compare and contrast the 10 most common herbs by dosage. We can see that the CUHK and guaizi have the positively correlations shown by the positive slope, and then for the Gonggang and Sangang, we have the L-shaped line, which means that they have a negative correlations, which justify our findings and our thoughts. Okay, this shows the herb hierarchy. Guaizi Tong in the blue box is actually the first formula in Shang-Han-Lun. It shows its significance because we have many formulae derived from Guaizi Tong Fong. Okay, for example, the Guaizi Ga Fuji Tong Fong, we will show it later. Guaizi Ga Fuji Tong Fong is actually, we will get a herb Fuji based on the constitution, the composition of Guaizi Tong. Okay, Okay, then we come to the formula origin finder. Okay, as we all know, this Gamfa is commonly used during the COVID-19 period. Okay, so we can see Shang-Han-Lun still shows its significance until now, Okay, we can see the 金花青咁火粒 actually include the composition of 麻黃湯. Okay, after we input the composition of 金花青咁火粒, we can see that it actually has a close relationship to two formulae. They are the 麻杏石金湯 and the 麻黃湯. Okay, the blue box is the 麻黃甘草杏仁石金湯. To make it simple, we would just call it 麻杏石金湯. Okay, in this table, we can see that when a formula is at a higher position, it shows a closer relationship to the custom formula. So, 麻杏石金湯 is the closest to the custom formula in terms of the herb species and the herbs. In terms of the herb species used. And second, we can see that 麻黃湯 is close to 麻杏石金湯 in terms of their herb species. Okay, and the relationship between these three formulae we can see here is that 麻黃湯 is actually used to treat cold, while 麻杏石金湯 is used to treat similar disease but not exactly the same as aforehead mentioned. We can see that in 麻杏石金湯 we have actually added one more herb, that is 石膏. It can remove the heat from our body to alleviate the fever symptoms in the patients, and also we can see that 桂枝 is removed because 桂枝 is described as a hot medicine herb in Chinese medicine. We don't want to add more hotness to the patient, so we take it out. Okay, we also have many other diagrams to show the relationships between formulae, such as this one. This is talking about the differences across formulae. So the darker entry it shows higher similarity between the two formulae. And the next one, it shows the composition of formulae by their herb types, which mean their herb resources. Like we have shells, we have fossils, we have minerals, animals, and plant medicine in Chinese medicine.
Now, we will introduce the quantity origin finder using a real-world case. In this medical case, a COVID-19 patient was prescribed by a custom formula from a TCM practitioner. For a TCM student, she may only know the herb species but have little idea about the source or the origin of the custom formula. So we'll build this origin finder for them to have a more thorough analysis, or maybe we can spark more idea for them. After inputting the dosages and the herbs, we found that 桂枝二月皮一湯方 is similar to the custom formula, and then the TCM student can to analyze whether it is actually true, or maybe it saves a lot of time to find a formula from the original text. Apart from the heat map and the comparison by herb type aforementioned, we have also visualizes the dosage trend and comparison by dosage. In this example, it shows the overview on all dosage trends. And in the next example, it shows the dosage trend for each herb mentioned in the result of origin finder. The last graph is to compare the formulae by dosage. In here, we can see that similar formula tend to have a similar composition. And finally, come to our conclusion. And we hope to build our searching tool for the TCM student, and it is interesting to combine data analytics and traditional Chinese medicine. This is our acknowledgement, and we sincerely appreciate the support from these parties. Thank you. This is the end of our presentation.
Thank you, Pong Pong and Jackie. Is there any questions from the floor? Librarian.
Hi. Yeah. One question. You mentioned about you using the herb list from Academic Sinica and the previous team. Do you find out any new herb slot from these two lists from your?
Yes, thank you for the question. We have found that around 20 herbs are not recorded in the list, so we add them to the list, and we hope that the future people can make use of the modified list. Thank you.
And this also shows how the meaning, the aims behind data analytics practice opportunity, that we would like data to be reused, which is a core component of research data management. And they have demonstrated they reuse the data that which has been polished and massaged in 2 years ago in the same event, and they further develop and massage the same data sets. And that is a good example of what we would like research data management, the meaning of research data management, yeah. And any other questions? If not, I would like to address one question to Pon Pon. And since you are a Chinese medicine student, that I would like to see, because you have been putting a lot of efforts in developing the Formulae, Origin Finder, and other tools too. So how do you think this kind of resources you have developed over these few months can be help in the study of Chinese medicine or other research?
Thank you for your question. Actually, during our study, we do not only focus on textbooks, but instead we also focus on some real-life examples, real-life cases from the modern TCM practitioners about how they use the formulae, how they modify the formulae by adding and taking out some formula. Okay, if we want to dig deep into those formula, we have to read a lot and lots of the Asian classic, which takes time. So if we can use this origin finder to help us to search, this formula is highly related to a formula which is mentioned in Shang-Han-Lun or in other classic. This really helps us to analyze the formula efficiently.
Okay, thank you very much, Pon Pon. And now, thank you both of you. And now we will invite the next team. Applause to them first. Yeah, we will invite the next team on data translation and visualization based on Zoumalou slip by Librarian and Bahrij. Thank you.
Okay, good afternoon, everyone. My name is Lyra, and this is my teammate Martin. And our group topic is data translation and visualization based on Zoumalou slips. Today, we would like to introduce about 3 parts of our content. The first is historical background narrative. Second is visualization demonstration, and the third part is translation sample. Let me start with an introduction of the historical background of our database. Zoumalou slips are a large number of bamboo slips dating back to the Wu Kingdom during the Three Kingdoms period. They were unearthed from an ancient well in 1996 in the vicinity of Zoumalou area near downtown Changsha, Hunan province in China, and that is how the name Zoumalou slips derived. The inscriptions in the slips are mainly from the years 196 to 237 AD, about 1800 years ago, with over 1.5 million words covering local politics, economy, military, and culture of that time. And about our database is a portion of the whole Zoumalou slips. They were containing the textual information from 2,141 bamboo slips records, containing the contents of land renting records by officials and civilians in the Changsha County during the 4th and 5th year of CUHK era. The textual information are compiled into the database by Professor Cheong and Professor Lai Mingqiu from CUHK and further edited by Master Liu Tianlang. And the database is now stored on the website of our CUHK history department and served as the source of our project. The Three Kingdoms period is a turbulent era in Chinese history. Due to the continuous warfare, the population suffered severe decline, and the agricultural economy was also heavily disrupted. After the establishment of the Wu's kingdom, the government implemented a land rental system on scattered state-owned lands, and Changsha County serves as an example of such implementation. In the bamboo slips, we can obtain some data like the recorded dates, specific locations, names and statuses of tenants, types and areas of rented fields, drought conditions, rental payments, etc. And we use those data for our data processing and visualization. So let me start with some visualization demonstration. And I would like to first introduce our methodology. We mainly use Python and Excel for data extraction, organization, and visualization. The raw text we obtain from the database is just like the picture shown above as a record. So we first snatch those possible numerical data from the text, and then we convert them to modern expression using functions in Excel and also using Python. Finally, we translate them into numerical data for calculation using some libraries in Python like Chinese 2 digits. And also, as for some data with different units, we also perform unit conversion according to the existing research of Zoumalou slips. And that is the part of the data table we obtained finally, and it is the source we use for our data visualization. The first graph is about a tenancy condition regarding tenant status. In the text, we find that there are several kinds of tenant statuses. We divide them into 3 categories. The first is civilians, including male and female civilians, as well as privileged civilians. Privilege means that their rent is lower than the ordinary civilians and have only a small portion in the civilian category. The second one is local officials, including officials of different levels and also officials in the army. You can see here the Zhou Jun Xian are the 3 levels in the Asian China local hierarchy in the descending order. And the third category is the soldiers. You can see in this graph as for the total rented area, the civilian, especially the male civilian, accounts for the vast majority, while the soldiers only account for the smallest proportion. We continue this topic and using these 2 graphs to show. In the right one, it is a graph about the total rented land area regarding those status, and you can see the darkest and the largest one is the land area rented by the male civilians and so on. And the left graph is the per capita rented land area according to different status. And as you can see, it is found that although soldiers rented the smallest area, however, their average rented land area is the largest and even much more larger than any other category shown in the graph. And besides, the privileged civilian and senior officials of different levels also rented a larger area than those ordinary civilians and the junior officials. Then we also took the regions into account and create the heat map. The x-axis represents the tenant status, and the y-axis represents the place names. In the graph, the deeper the color is, the largest the rented area is, and we can see more clearly in that graph, which is a zoom in view of the upper left corner of this data, and we can easily see the regions with the largest rented land area regarding different statuses. We also analyzed the number of records regarding delivery time and also the rent payment time. In the left graph, we can see the period starts from September and continues until March in the following year, but mostly they concentrated in November and December. That's because in Asian China, in the late October, it is time for the farmers to finish their harvest and to count the crops they have harvested. If they unfortunately encountered drought conditions, their rent may be reduced according to the severity of the drought. So it also takes time for the local officials to decide on the final rent they need to pay. That's why their delivery time is concentrated in November and December after the October. And in the right graph is a scatter plot of records with data precise to date. We would just like to compare the 2 years of records to see whether there are some differences between 2 years regarding the delivery time. However, it seems that in terms of the delivery time, the situation of Jiahe, the 4th year and the 5th year, is relatively similar. And actually, there are 2 land types existing in the text: standard field and the extra labor field. The rent of standard field is fixed and in the 2 years of tenancy term, while for the extra labor field, the rent may be flexible and can be adjusted by the local officials. And the left graph is a hexbin plot joined with some bar grams. It shows the relationship between extra labor field area and the standard field area in different regions. And we can see that in most regions, the standard field area is in the range of 0 to 500 mu. Some may even reach more than 2,000 mu. But for extra labor fields, the largest one is only 200 mu. That is the differences. And for the right graph, it is about land types proportion and area by regions. And from that, we can easily see that the standard field always accounts for the largest proportion of the rented land area in all regions, and that means in most cases, the renting time and the rent is fixed and regular for the tenants. And the last 2 graphs are about the drought condition regarding different regions. The left one shows the overall proportion of drought fields over the 2 years, and the right one is a comparison between 2 years of different regions. Actually, we can see the drought is commonly encountered in the period of time, and some may be even very severe in some places like Baqiu and Xiaoqiu. And it is consistent with the existing research that actually there is a drought hit the Changsha County in the period around the 4th year of Jiahe to the 5th year of Jiahe. but we can also see that the drought condition may vary from places to places and from time to time, and these are the visualization results we have obtained through the process, and it's time for the translation part.
Okay, thank you for my teammates Laura's visualization part, and I will continue with our translation samples. So earlier we have mentioned some of our visualization charts and some conclusions we made to the visualization part. But if you are looking back to our original text, it is looks just like exactly like this. It is made up of some bewildering ancient Chinese, and if we, even though for example, I'm maybe very I have a deep learning in Chinese, but I can't read from this original text directly. So even not possible or ideal for those who are not familiar with Chinese to read through this original text to get our result in the visualization part. Sorry. And so actually, in order to solve this problem, we have improved current translation models for the ancient Chinese text to better interpret the original data set. Our translation model relies on the natural language processing and the large language modeling with three main features shown here. The first feature is a feature word extraction, and the second part is a predictive translation of LLM engagement, and the third part is adoption of the conventor. And so firstly, I would like to demonstrate the feature word extraction using cross-reference translation of feature words as an example. So what I mean by the feature words here, so actually in short is the hardest part to understanding our so actually it is the hardest part for us to understand in our original text. So in this sample sentence, I list three phrases here in both Chinese and English by comparison. So this one is 余力田 in Chinese is means as a field cultivated by termites themselves in English, and so as the middle one and the last one. So once we have the translation of this feature words, we could better understand what our original data sets are talking about. So so after getting some feature words in our original data set, we adopted the Python package Jeba, which is specialized for ancient Chinese text to make the word segment. So we use it to finding recurrent feature words in a segment based on the word frequencies the statistics. So this is the original code. I put it here, and after adopting that Python package, we could make some statistics, and we could see the example 母收部 I mentioned before is also appeared here with a frequency of 2126. So it is a relatively high frequent word. And once we got a list of our feature words, we could locate their location in our texts, in our original data sets, in our the text we are trying to relate from the original data set and our visualization part. So this is an example that optimizing the corpus. So actually, I put a column, or sorry, not a column, but a row in the data in the original Excel into the Python, and this is a result before optimizing the corpus. So so actually, it is chopping up some intervals into parts. So actually, if we put some sentences just like the feature was extraction, these three words into the Python, but it is in ancient Chinese, so it would likely to be chopped up by feature words. So this is one phrase, but it will be recognized as a word in this Python program. And for the extraction, it may be misunderstood and chopped up by extra and action in that original program. So after the adjustment here, some core code here, after the adjustment, it would be correctly recognized as feature was extraction in our program. So this is the first line is 下午秋 means location, and the second one 君力 means the identity of the people, and this one 黄源 is a person's name. So in this example, you could make a comparison between this one and this one. So so this actually these three characters forms a location, but it is wrongly wrongly outputted in this program. And that so the before that is some feature words extraction, and now we are going to the overall structure of the BRT model. So what's BRT stands for? It is a specific transformer model proposed by Google recently in recent years, and it is for some natural language processing. And this is overall structure, but I will not like to talking about the embeddings because it's way too complicated, and due to the time limit, we will only concentrate on this network structure of so on this network maybe mapping structure, and I reconstructed it to better suit our case. So. Before, maybe the mapping structure in the BRT model is like this. It has two layers or two hierarchies, and after our adjustment, it is merged into one, and we also done some simplification due to the contributions of the NLPCC 2023. Okay, so I will go quick and. So after we construct the mapping constructor of the BRT model, we also adopted the ChatGPT for our translation, because it is very suitable for NLP and LLM tasks. Mainly follow these 4 steps. So we are using the former BRT model to provide some tensor and some tokenizer sequences of the text, and then input them into the ChatGPT, and then to give some promote to the ChatGPT, and use it to finish the remaining translation task. So I will give an example. This is the original text in our Excel, and this is translated text marked in blue color. And if you can read Chinese, you could see that the translation result is easy to understand and some way fluenter. Yeah, more fluent. So as I mentioned, we also adopted of the conventor because we considering the reader maybe have different language preferences, maybe in Chinese, maybe in English, etc. So the original output is in traditional Chinese here, and you could see that after all the work we done, so the result is very accurate, as some dummy words also be added into the translation result for the fluent and the accurate result. And so lastly, I will demonstrate the English version. So this is a bridge one because original output length is huge. So I will only show these sentences, and you can read from it directly, and you may make some comparison to our visualization results. So in summary, the data mining of the text translation of the LLM makes visualizations organically connected, so that readers can better appreciate the causes of the changes in field text and money between the charts, and the historical origins against the translated text, and have a deeper impression of the times as far back as thousands of years ago. So thank you very much. And so anyone has any questions?
Thank you very much, both of you, for your presentation on the Zoumalou and the historical period. Any questions? May I ask that there are a lot of visualizations that you have been doing. So how do you think these visualizations can enhance the study of the Jiahe historical period and the Changsha location?
Well, thank you for your question. We think first we have converted those text data into numerical data, and we store them in a suitable format which is convenient to use, so that we also classify them and organize them so that when researchers need some specific data, they can simply use our data and simply fetch them and use them. No need to translate, or no need to convert them into numerical data. That is the one reason. And second, we have done some visualizations, and we think we have shown some intuitive correlations between the factors, like the tenant status with the regions with the rented land area, and also the drought conditions and the regions. We think those correlations can help the researchers get a general idea of the condition in the certain period of time in the certain location. Thank you.
Okay, thank you very much for both of you, and thanks very much for them. Next, may we invite Raphael Dur and Chao Zhu to tell us something about the CUHK research. Their topic is Departmental Landscape at CUHK, Mapping Tiles Using Graduate Thesis from 1967 to 2021. Thank you.
Good afternoon, everybody. So we're both PhDs from the sociology department, and we spent the last several months attempting to create, we worked for the last several months with this electronic thesis data, and we attempted to show ties between departments and to visualize the interdisciplinarity between them. So very quickly about our motivation behind it. So as a major public research university, CUHK is an enormously complex educational institution institution with many different departments, schools, programs, divisions that are tied into faculties. And yeah, it has many administrative levels. And departments are evidently kind of important in this, as staff and students spend most of their time working in departments and dedicating their output to them and working in the name of their departments. So what also connects them is shared ideas. So researchers from different departments do share interests, research interests and what they want to do, not necessarily in their methods and interpretations, but they might work on similar topics that they're not even aware of that other people are also doing. So our goal was kind of to explicate this network of ideas that connects the departments. So we use the CUHK electronic thesis and dissertations repository from the CUHK library. Up to date, it contains around 20,000 theses since 1967 in full versions and with metadata. And so we downloaded them and we retrieved certain information from them. Including this is an example of one of them, by the way. So we retained the title of them, the degree, the department or the division, the subject, and the language it was written in. So a few descriptors from these from the data set. It's a bit blurred here, but I guess you can still read it. This is an example of the frequency distribution of the departments. So, for example, we could say that 4% of the theses from this repository were written in or by students of the Department of Chemistry. So we put the departments manually in their home faculties. So again, here we could say that around 4%, as an example, of the theses were written by students from the Faculty of Education. And finally, we put them into their academic areas. And again, here we could say that up to 53% were written in a STEM field or STEM-related department. So we are aware that, I mean, it's kind of obvious that we have a certain bias in our data, that most of our analysis is based on post-2000 data. As you can see at the beginning, from the years 1967 to around 2000 or so, there's much less data available from them. So most of our findings are biased towards more recent times. So just two examples from this data here. We can also see that most of the theses are, they're overwhelmingly written in English. And also like that since around the year 2000, that the growth of PhD thesis in this repository is much stronger than the master's thesis. But overall, the number increases. One last step before we then got to the visualization. As several other groups, we also, it's not really important that you can read the text here, but that's the format how it was. But as several other groups, we also used natural language processing to work with text data. So we used the titles and the subjects. We cleaned them of some things like pinyin words, number symbols, and so on. And from this, we estimated the correlated topic model, and at the end, we were left up with 15 latent topics. And these topics were then used as mediators between different nodes of the departments. So they created the ties between them.
Okay, thank you. Thank Rafi for laying out the background and introduce the method. Now let's look at our result. First, it's a graph by the aggregated thesis. I'll first explain this figure a bit. It's a little bit blurred, but I believe you can see the nodes clearly, that each node represents one department, and there are 56 departments on this figure. And how about the ties connecting those departments? Well, take department Department of Social Work and Architecture as example. So they all have numerous theses, and if by the previous step of the topic modeling, that social work department covers topic number 1 in their thesis, and the thesis of architecture also covers topic number 1, then we'll create a tie to connect them. And one more concept in this graph is that we assign weights to each of the tie. The weights means the number of shared topics, because in previous step we predefined 15. The bottom map number of topics is 15. So theoretically one department at most could cover 15 topics, although empirically it could not. Well, now let's look at some distribution of these weights. So in this first figure, I show you those ties that connect two departments with exactly one shared topic. And this is the figure with ties that's with exactly 2 shared topics. And this is 3. You can see the figure become more and more sparse. And eventually, none of the departments would share more than seven topics. It makes sense because none of the departments would cover every topic in their graduate thesis. And here's also some overview of this network basic attributes. The first is that we notice among these 56 departments, around 74% of all possible ties are realized. What are all possible ties? It's just all kinds of combinations between any 2 departments. And 74% of them are realized. So it's a pretty high number. We could say that this is a dense network. And also, we calculate the diameter, which is any department can reach any other department within 2 steps. So we will also say this is quite a compact network. Okay, now let's look at some comparison between the subsamples of this thesis. The first comparison is between the PhD thesis and the master's thesis. The first graph is, this is the master thesis network, and this is the PhD thesis network. So visually, the PhD thesis network looks a bit more sparse than the master thesis. But overall, when we check all those basic network properties, they are very similar. Just one major difference is that PhD thesis seems to be more specialized and less interdisciplinary based on the modularity matrix. Well, this is just one way of our interpretation. You can check the direct evidence in the website later on to have your own interpretation. And another comparison is the subsample before and after 2012. Why we choose this time point? Because there's a major institutional reform in this university that the 3-year study scheme of undergrad switched to a 4-year study scheme. We saw this as an indicator of the overall institutional reform of the university. So we guess it could be some difference. So actually the 2 graphs visually looks very similar. And when we look at all those matrix, the metrics
surprisingly, the two networks are also very similar. But as I just showed you, as we just discussed, the data is imbalanced across time, so comparison across time point is very challenging, and this similarity is just a very tentative claim. Okay, so the final message we thought really interesting is the comparison between the algorithm detected clusters versus based on the network, the tie weights, and the institutional faculty setting. Okay, so there are in total 8 faculties in this university, or faculty level institutions. So on this left-hand side graph, you don't need to read the labeling of those nodes. You just notice the color. The color is meaningful here, that we let the algorithm to detect 8 clusters based on the ties, their network properties. But here, for clarity, I omit the information of tie. But remember that this color is solely based on the ties, and we have we let it as a partition to have 8 clusters. So each color represents one algorithm detected cluster in the left-hand side figure, and we order them in a way that nodes with the same color are put together. And to compare it, we fix the position of the node in the right-hand side figure. So both figures, the nodes are identical, the positions are identical. The only difference is that on the right-hand side figure, now we color them by the institutional faculty. So any 2 nodes who share the same color means they're in the same faculty. And now you can see that for this area, the color here are mixed. Mixed means that those departments grouped into same cluster but by the algorithm are not in the same faculty, or those 2 departments in the same faculty are not grouped into same cluster here. So, and also we further calculate the adjusted mutual information of this 2 partition scheme. The result tell us that roughly to make this partition, the institutional faculty, exactly identical as this partition, we need to move around 45% of the departments to reallocate them to make the 2 partitions exactly the same. Of course, this is not a bad news. It means that the commonality across faculties are more than we might expect. And so this is the final figure, and this is the partition based on the commonsensical academic areas. So on the right-hand side figure, we use this predefined scheme as STEM, social science, and humanities. So the same color means in one of the 3 academic area. And to compare them, again, we fix the nodes and the positions. On the left-hand side figure, it's the algorithm detected communities. And what's interesting in the left-hand side figure is that, so if we bottom up, classify them by the topic of the thesis, the social science and and humanities departments, they are grouped together, while within the STEM field, they are split into 2. And there are some regularities that STEM 1 and STEM 2, you can see that if you later on you go to the website and look at the department names, you will see that one among them, the departments related to life science and medicine, they are grouped together. They form a more compact community, and all the other STEM fields are in another community. Okay, now let's welcome Rafi again.
I don't know, I would just say the third one because our time is up also now. So, of course, this doesn't mean like, even though it would be maybe empirically a bit more logical, but we're not advocating like for restructuring the CUHK structure, because I mean faculties and departments are also historically grown decisions. This is not something that should be done like purely on data, but we also find it pretty nice to see like in an event like this, because there are people here from other departments like Chinese medicine or geography that I have no idea what they're usually doing. So it's still interesting to see that you might share more similarities with them, like using same programs and also maybe sharing same research methods or so, and just sharing same interests. So maybe as a very distant outlook, we would find it really cool that if students had a way to access this, if they could find a way to input their idea and see at which department there might be like the same idea might also be covered by some of the students. Okay. So,
Okay, thank you, Rafael and Steve. Are there any questions for them? Ryan.
Thank you. From your take-home message, I saw the first one about so I can give you a chance to talk about this. So some departments remain in a relative isolation. Could you talk more about that?
Yeah, there are departments which are just very specialized. I mean, when we saw the split in the STEM fields, for example, all those life sciences and medical departments that were grouped together, I mean, they share a lot of common topics, but do you have an example for one that is? I think it was fine arts or so, who is really a bit yeah, the ones here, for example, like China studies or linguistics and modern language, it just means they have a relatively low probability to have to be allocated to one of the topics that we found, so in the latent topics. But we didn't really analyze the departments themselves. Like we cannot really say much about why that is the case. Why specifically China studies does this from their curriculum. So.
Any further questions? If there are no more questions, thank you very much. I'm sure this kind of graphs will be useful, especially for new starting research students to learn how they can get to collaborate with other departments when they start their proposal and their work in their research. Thank you, both of you. Finally, let's invite Chen Bao, Zhihan to introduce their project investigating the impact of marine heat wave on seagrass species, a machine learning approach.
Okay, so hi everyone, we are the last group. Unlike all the other previous groups that working on history or humanities related subject, we are working in the field of biology. And our project title is investigating the impact of marine heat wave on seagrass species, a machine learning approach. And through this project, our objective is to apply various statistical methods to analyze the dataset, develop machine learning algorithms to train models, and deploy data visualization skills to enhance our research outcomes. Integrating these methodologies, we aim to gain insights into the relationship between seagrass presence and
marine heat waves. Furthermore, understanding the role of seagrass species in surviving under the impact of marine heat wave is crucial for effective management and for protecting our ecosystem. But before we start, let's go over the outline of today's presentation. We introduce the data set first, and we move on to the analysis of our data set. And based on the analysis results, we use various visualization skills to visualize our results. And finally, we will tell an exciting story from our results. And, but before we actually start, let me ask you a question. What do you think are the key factors that influence the successful growth of a seagrass species? You might instinctively consider sunlight, oxygen, temperatures as the answer, and you are right. The growth of seagrass is indeed influenced by many factors such as sea surface temperature, water currents, solar radiation, nutrients, oxygen, and many other things. In this study, we mainly focus on the influence of the SST, that is the sea surface temperature. But as our investigation progresses, we will unfold the complex interplay among all these factors. The main character of this project are two tropical seagrasses. As you can see on the figure 2 and figure 3, they are H. ovalis and H. becari. These seagrass species are not just prevalent in Hong Kong's waters, they are also important in sustaining the equilibrium of our marine ecosystem. To understand their world, it's essential to comprehend the anatomy of seagrass. The image figure 4 shows the various components of tropical seagrass plant, including leaves, rhizomae, and roots. These three parts are the main focus of our project. And finally, let's spotlight the marine heat waves. A main character defined by usually high ocean temperatures that exceed the average for a specific marine region. These events are becoming more and more frequent and intense due to global warming, with profound implications for our marine ecosystems. And with all this background knowledge, let's start introducing our data set. Let's focus on two key points: how the data is generated and what is the data set about. The raw data is generated from a 10-day experiment. This experiment aimed to elucidate the impacts of elevated temperatures, specifically a control temperature at 23 degrees compared to a heat wave scenario of 27 degrees on H. becari and H. ovalis. These seagrasses were carefully collected from two distinct locations in Hong Kong, as you can see in the figure 1, Deep Bay and Tung Chun Bay respectively. The experiment set up monitored the seagrasses' responses to these temperature regimes with pre- and post-experiment measurements, including rhizome length, leaf retention and growth, new rhizome and root development, leaf generalization, and overall biomass, offering a comprehensive view of their adaptations to marine heat wave. Let's look at one of the concrete example. It's one of the raw data set of this experiment. It's the leaves data set. To the right-hand side of this chart is treatment and species. These two columns classify the data. And to the left, they are leaf 1 and leaf 2 and leaf 3. They are the length of the leaves after the experiment. And old leaf 1, old leaf 2, old leaf 3 are the length of leaves before the experiment. So the minus is just the difference between these two values, indicating the growth of the leaves during the experiment. And the rightmost column is largest new. It is just the longest leaves during this experiment. So it's very clear. And let's move on to the analysis of the data set. A typical workflow using machine learning approach is like we first pre-process the data, transforming our data into a format conducive to model fitting. This includes encoding categorical data and normalizing values. Then we select appropriate features to fit in our model. By building a machine learning model based on that, we can further evaluate the output by validating the data. So upon pre-processing the data, an obstacle we met was the missing of some data in the data set. As you can see in the figure 1, it's the root data set. There are some blanks, so it's very annoying. So we know that after discussion between the owner of this data set, we know that it was due to some of the leaves died or were missing at the end of the experiment. Missing data causes problems as we did not have enough input data to ensure our model's accuracy. We thus introduced KNN algorithm, as you can see in the figure 3. You can refer to this figure on slides to have an intuitive and straightforward overview of this method. It's just filling in the blanks using the average of the values of k nearest neighbors. Now that we have well prepared, let's move on to feature selection. Feature selection is important in building an accurate yet efficient model. The selection criteria are a careful balance between the dataset's characteristics and our research objectives, often honed through iterative testing. Let's take the rhizome dataset in the figure 1 as an example. As you can see, first this is treatment and species, and to the right-hand side, it is star, and minus, which is just the rhizome length before and after the experiment, and the difference between, that is just the growth of rhizome length during the experiment. So what parameters or what features will we choose in our program? Treatment, and you can refer to figure 2. Treatment and species are obvious because it is the classification of the data. And minus is also chosen for its direct presentation of the growth length, which is the objective of our study. So let's move on to the mode development. One of our choices is implementing random forest algorithm. Random forest is an ensemble learning method that combines the predictions of multiple decision tree models for regression or classification. This approach enhances the model's accuracy by incorporating randomness in feature selection and data subsets, preventing overfitting and boosting predictive strength. And our model's output has been translated into a series of box plots, offering a comprehensive visualization of our findings. You may feel you may at a loss, but don't worry, I will explain it in detail later. And but notice that not all of the visualization results are valuable in terms of getting exciting insights into the relationship between marine heatwave and seagrass. So we will just choose 3 of them to show our findings. And let me talk about in detail the first aspect, rhizome length and biomass. You can refer to these 2 box plots in the right-hand side. The first one is rhizome biomass, and the second one is rhizome length. So how to read this box plot? So you can see that the blue one is we are using control treatment, that is no marine heat wave, and the red one is under marine heat wave condition. And the left-hand side is the species H. beccarii, and the right-hand side is the species H. ovalis. And this line is just the median of all the data. So we can just choose this black line as our investigation object. So we can read the plot directly and find the following findings. Biomass of H. beccarii changed very slightly, while H. ovalis increased more significantly. And for the rhizome length, all of the 2 species change basically the same, while H. ovalis still has a higher rhizome length. And the right-hand side figures are just our raw data. So let's move on to the next aspect, that is leaf turnovers. You can still read the plot that you can find that the species H. beccarii, the leaf turnovers increase significantly after the experiment, and while H. ovalis, they did not change. So we can conclude that while H. ovalis was unaffected by the marine heat wave, H. beccarii thrived under marine heat wave conditions. That is, although the surface area of H. beccarii leaves present at the beginning of the heat wave decreased to a great extent in the marine heat wave treatment, possibly due to increased decomposition rates with higher temperatures, the greater production of the new leaves in the experiment means that overall these species were resistant to the event. Therefore, this study revealed that spring marine heat waves may not be harmful to seagrass survival and growth in Hong Kong. Bahrij can explode the increased temperature, which is within the tolerance range by it, and by boosting its leaf turnover potentials. Finally, let's move on to the root length. We can still read the plot that you can see both Bahrij and obelisk decreased a lot in terms of root length after the experiment, while while the difference of Bahrij is higher than the obelisk. So we can conclude that this study also indicates that increased temperature from a marine heat wave can affect the root length of Bahrij, which was lower under the marine heat wave treatment. Reduced root length can be a self-thinning mechanism of the seagrass in response to high seagrass density. Although the seagrass in the experiment was not overcrowded, there was higher above-ground biomass of Bahrij under marine heat treatment by the end of the experiment, which may have generated this response in root length. There are various negative consequences of restricted root length, such as decreased resistance to hydrodynamic exposure and reduced capacity to absorb nutrients. However, lowered root length can also shorten the path length for oxygen supply. This change can be beneficial to the seagrass, particularly as the oxygen requirement for respiration is higher under evaluated temperatures. Therefore, in response to marine heat waves, shorter root length may be advantageous and facilitate increased respiration rates, as the plot illustrates. So, with the visualization results and some basic findings, let's talk about the findings of our project. First, let me tell the background of our research project. The project is very related to the current global warming ecosystem, climate change, and other anthropogenic impacts can drive large-scale effects on seagrass, with these meadows disappearing at a very rapid rate, making them one of the most threatened ecosystems in the world. And seagrass ecosystem is also one of the most important ecosystems in the Earth, the study of marine heat wave and seagrass is of utmost significance in terms of protecting our environment. And our overall conclusion is that short marine heat waves in springtime pose no significant additional threat to the survival or growth of these two seagrass species. These two species show great resilience under thermal stress. But however, while the results of this study demonstrate the encouraging and positive results, longer marine heat wave events can also increase the severity of these seagrasses. Moreover, stresses co-occurring with marine heat waves can lead to more bad effects, such as changes in turbidity, which can have much larger repercussions on the seagrass ecosystems. In large coastal cities such as Hong Kong, land reclamation, pollution, and human activities can threaten coastal habitat and threaten the living of these seagrasses. These disturbances, along with marine heat waves, may increase the currently observed patterns of global seagrass loss. The ongoing presence of these seagrasses will have an important role in shaping the associated floral biodiversity. The reduction of further biodiversity loss with the current global decline of seagrasses, our results are encouraging for these important habitat formers, as we show that warming events may not necessarily lead to ecosystem collapse. However, by understanding more about the responses of different seagrasses to a potential environmental threats, conservation strategies can be adjusted to their individual habitat requirements, so that recovery capacity, even under marine heat wave events, will be important given the ecological functions of seagrasses, such helping to support and build and recover the biodiversity and habitat complexity in the environment or coastal cities such as Hong Kong. There's also an association in Hong Kong called HKSR, that is Hong Kong Seagrass Restoration Association, who is already doing related work to protect the seagrass ecosystems in Hong Kong. And that's all for our presentation. And we want to thank the Professor Falkenberg and Dr. Bass in the School of Life Sciences for sharing the data set and give us valuable ideas during the project. Thank you.
Thank you, Chamber, and thank you very much. And it's an interesting topic that brings us to our ecosystem and using data sets from our CUHK research data repository. And I would like to see if there are any questions from the floor. If no, may I ask, as the last group here, and you have drawn data sets from the CUHK research data repository, but my understanding is you are from mathematics and information engineering. So why do you come up with this topic? Because it's very different from your study.
Why do we come about this topic is mainly because the first reason is that the ecosystem of marine is very important to our environment. And the second reason is that all of our teammates do care about interdisciplinary collaboration. I think that our job due on this data set can actually help the research related in biological area to find out which aspects can most affect the seagrass to better facilitate the species to survive in the species. For example, from our research, we can find that some of the resume of the kind of the seagrass can actually survive better in the marine heatwave. So for the biological person, they can actually dig out the gene to to build some new species to make it more suitable for the marine heatwave.
And I want to mention that I'm also doing a project with one of the professors from computer science department, but it is in the field of bioinformatics. That is just a combination of computer science, all these machine learning methods with things in the field of biology. So I think it is familiar for me to conduct this kind of a project. Yeah.
That sounds great. Because it shows the interdisciplinary collaboration on different disciplines across our different departments, from engineering to life sciences and also biomedicine, and so on and so forth. And thanks very much for you two. And that comes to the end of all the presentations. And now may we invite Dr. Wong to give some comments to our students. Dr. Wong, please.
Thank you very much for the presentation. I think all the work done are very wonderful, right? So they are of very high quality. And I'm pleasantly surprised that you can master those advanced topics and techniques in data analytics, like LDA, the bird model, various techniques for the visualizations, social network analysis, machine learning. All these are quite advanced topics in data analytics. I'm pleasantly surprised that most students can master these techniques. So I think these activities are very successful. Yeah, thanks to the effort by Wendy, Nini, Kitty, and hope this kind of meaningful activity will continue next year. Yeah. So may I say a few words about the topics, right? Sure. The presentation. The first one, I'm very impressed by the timeline, right? Very sophisticated visualization, very impressive, right? For the second one, for the wartime story, I agree with the comment by Dr. Kwong, right? Probably further work is about to build a 3D model for that to get more attractive. And then about the third one, the knowledge graph. This is a very advanced topic, right? And I really impressed by your work. It's difficult to construct a knowledge graph. It's a difficult topic in NLP, right? And then the fourth one is the Chinese medicine. I agree with Wendy, right? This work can be extended, probably makes contribution to the teaching and learning of Chinese medicine, right? And then the fifth one is about the bamboo slips, right? So the student using the Berk model, right? So transformer model to tackle the Asian Chinese. So translation, I think it's very sophisticated. I'm very impressed by that. And then the next one is using social network analysis, right, for the topic modeling. So it's also very impressive, and it can aid, facilitate the collaborations among the departments. Okay, the last one is the seagrass species, right? I think very meaningful, right, for the ecology. So, okay, all these are very meaningful work, wonderful work. I hope they can be continued next year. Yeah, thank you for all your effort. Yeah, thank you.
Thank you, Dr. Wong. Thank you, Dr. Wong, for your comments, and that's very meaningful to our students and to our projects over the past week. And as time is running short, and we have to put this presentation to come to a close. And this also concludes the Research Data Management Week 2024, organized by the CUHK Library. We are grateful for your participation in the events today and over the past week. We are also glad to the supports from colleagues in our CUHK Library, members at CUHK, and speaker and audience from around Hong Kong and other parts of the world. Research data management is an essential part in research. We hope the events in this Research Data Management Week has aroused your attention on and knowledge on RDM. Should you have any questions, please feel free to contact us, the research data team at CUHK. We look forward to meeting you in other events. Thank you.